One is interchange of two rows, or any row is multiplied by a scalar, or to any row or column a scalar multiple of another row or column is added. These are the three elementary operations. The same operation can be applied for column also. So elementary row operation is there, elementary column operation is there. So we can find out the inverse of matrix by elementary row operation or elementary column operation. And let me explain this finding out the inverse of this matrix A by elementary row operations. Or what is the first step is that we should write A is equal to I, where I is the identity matrix. So here A is, that is 2 0 minus 1 5 1 0 0 1 and I, you know I is the identity matrix 1 0 0 0 1 0 0 0 1. This A I am writing A itself. Our aim is to apply the elementary row operations for this and reduce this matrix, the left side matrix, into an identity matrix. So when you apply the elementary row operation here, the same elementary operation will be applied here also. So when you apply the elementary operations and reduce this matrix into an identity matrix, automatically this matrix will be changed to another matrix, and say I call that as B and this is A. So you get I is equal to BA. Then automatically we call that B is the inverse of A. That is what the process. That means we need to apply the elementary row operation. There are three elementary row operations: interchange the rows, and then multiplying a row by a scalar, and third one is to any row a scalar multiple of another row is adding or subtracting. So that is what the process. So your concentration should be how can we reduce this matrix into an identity matrix. So you know that for an identity matrix the first element should be 1. So I am going to apply R1 as 1 by 2 R. That means the first row is multiplied by 1 by 2. So what will be getting here? 1 0 by 2 minus 1 by 2, and the other one is 1. So when you apply here, that should be applied here also. So you are multiplying the first row by half. So 1 by 2 0 0 0 1 0 0 0. Okay. So one step is over. Next step, I am trying to make this is 0 because for an identity matrix this element should be 0. So how can I convert R2? I want to change this R2, this element as 0. So R2 is R2 minus 5R. To any row, a scalar multiple of another row or can be added or subtracted. So to convert this into 0, I am multiplying here by 5 and subtracting. So what is the things comes? 1 0 minus 1 by 2. 5 minus 5 because multiplying here by 5 and subtracting. So this becomes 0. Then 1 minus 5 times 0. That is 1. 0 minus 5 times this one. So 0 minus 5 times this one is 0 plus it comes. So it is 5 by 3. 0 1 3. The same thing is to be applied here also. This is half 0 0. So what is happening? This minus 5 times. So 0 minus, that is minus 5 by 2 will come. 1 minus 0 minus 0 0 1. So the first column has come and here also it has come. Now you have to convert this into a 0. How do you convert this into 0? That is R3 can be taken as R3 minus R2 because 1 minus 1 gives it. So I will be making it R3 as R3 minus R2. R2. Let's see what is that. 1, 0, minus half. Then 0, 1, 5 by 2. What is R3? R3 minus R2. So 0 minus 0. Then 1 minus 1, 0. Okay. 3 minus 5 by 2. 5 by 2 means 2 and a half. So 3 minus 5 by 2 means 3 minus 2 and a half. We will get half here. So the same thing is to be applied here also. That is half, 0, 0, minus 5 by 2, 1, 0, 0, 0. Sorry. The last one what was R3 as R3 minus R2. So 0 minus, so it becomes 5 by 2. Okay. 0 minus 1, that is minus 1. 1 minus 0. Now you know that this should be 1 for us. So I can take this next one as R3 as 2R3. So this becomes 1, 0, minus half, 0, 1, 5 by 2, 0, 0, it becomes 1. And that should be applied here also. Half, 0, 0, minus 5 by 2, 1, 0. Multiply the third row by 2. So it is 5 minus 2. Now what are the next steps required for you? We require here, that is this is to be converted into 0. So how do you convert this into 0? This you can make it as that multiply here by half and adding here. When you do such things, you should ensure that the other thing should not change, because once again it change, it becomes repetition like this. So because already this is 0, so I am going to multiply this by half and adding here so that this remains same there. So what is that? R1 as R1 plus half R3. R1 as R1 plus half R3. So what will happen? 1 plus 0, that is 0 plus 0, that is minus half plus this half. So it is 0. 0, 1, 5 by 2, 0, 0, 1. And here it is half, 0, 0. Sorry, I have to apply here this also, no? So what is the R1 as R1 plus half R3. So half plus half R3, half plus 5 by 2. So 1 by 2 plus 5 by 2, 6 by 2, this comes 3. 0 plus minus 1 will come, because half is there, half of this one. 0 minus 1, that is, then 0 plus 1. Then minus 5 by 2, 1, 0, 5, minus 2, 2. Okay. Now what is the next stage? We have to make this also 0. Because in the implementing this is also, how can you make it 0? You multiply this by 5 by 2 and subtract. So what is the next operation? R2 is R2 minus 5 by 2 R3. R2 is R2 minus 5 by 2 R3. So here 1, 0, 0, then 0 minus becomes 0, and when you multiply it becomes 1. 5 by 2 minus 5 times here, so that is 0, 0, 0, 1. So what is the operation here done? 3 minus 1, 1. What is the operation? Minus 5 by 2 minus 5 by 2 R3. So minus 5 by 2 minus 5 into 5, 25 by 2. So how much becomes? Minus 5 minus 25, that is minus 30 by 2, it's minus 50. Then 1 minus 5 by 2 into minus 2. So it is 2 cancels. So 1 plus 5, it is 6. Then 0 minus 5 by 2, 0 minus 5 by 2 into 2 is minus 5. Then 5 minus 2. So with this we could succeed that the left side matrix were completely converted into the form of an identity. So the product of these two gives an identity. That means this is the inverse of it. This is the process we should do it. Every problem, the only thing is that you should not make any hurry for this one. Slowly you should think. See, what I want to say is you write A equal to IA and this is A, this is. We will be trying to convert into identity. So first step by step we should go this way.